Good morning to all of you. Now we are going to discuss about binomial distribution. Before discussing binomial distribution, you have to know about Bernoulli trial. Bernoulli trial is what? The trial having two and only two results are called Bernoulli trial. For example, when a coin is tossed, we get only two results, that is head and tail. So tossing of a coin is an example of Bernoulli trial. The French mathematician James Bernoulli introduced the concept of Bernoulli trial. Therefore, after his name, it is called Bernoulli trial. Before giving the definition of binomial distribution, let us take an example. Suppose four coins be tossed. Then we get four independent Bernoulli trial. Here, each trial may be either in a head or in a tail. If we get a head, we call it a success. Suppose if we get a tail, we call it a failure. And success is denoted by S. Suppose failure is denoted by F. Let me consider that probability of success, that is probability of S is P, and probability of failure is Q. Suppose we are interested in getting the probability of 3 success. Then it can happen in any of the four mutually exclusive form. That is, suppose we toss four coins. Therefore, if we consider in getting the probability of 3 success, then the mutually exclusive forms are like as SSF, SSFS, SFSS, and FSS. Thus, we get 4 cases, and 4 is what? 4C3. And see that the probability for the first cases, that is the probability of SSF, is what? Probability of S into probability of S into probability of S into probability of S. This is only because of the trials are independent. Therefore, the probability of because the trials are independent, therefore probability of S F equals to probability of S into probability of S into probability of S into probability of F. And we consider that probability of S equals to what? P. Therefore, this one will be P to the power P into P into P. This P to the power 3 into Q, and Q may be written as Q to the power 4 minus 3. Therefore, we get probability of SSF equals to P to the power 3 into Q to the power 4 minus 3. Since the trials are independent, therefore probability of each of the cases will be P to the power 3 into Q to the power 4 minus 3. For example, take as probability of S, F, SS. This one will be what? Probability of S into probability of F into probability of S into probability of S. And this will be what? Probability P to the power 3 into Q to the power 4 minus 3. Since all the 4 cases are mutually exclusive, therefore required probability will be what? P to the power 3 into Q to the power 4 minus 3, P to the power plus P to the power 3 into Q to the power 4 minus 3, and we added this term into up to 4 times. Therefore, required probability will be 4 into P to the power 3 into Q to the power 4 minus 3, and this may be written as 4C3 equals to 4C3 into P to the power 3 into Q to the power 4 minus 3. Here see that we toss only 4 coins. Suppose if we toss n coins, then that will be what? NC3, NC3, and NC3 where P to the power 3 into Q to the power n minus 3. Suppose if we write the n in place of 4 and x in place of 3, then we get the general form of the binomial distribution. And let us take the definition of binomial distribution. And binomial distribution is a discrete probability distribution. Therefore, in the definition, we consider the random variable x as a discrete random variable. A discrete random variable x is said to follow binomial distribution if probability mass function of x is given by in this way. Probability of x equals to ncx into p to the power x into q to the power n minus x. Here x is what? 0, 1, 2, 3 up to n. Here see that n is a finite number, n is small, and p is what? P is the success. P is the success and q is failure. And we know that total probability is always 1. Therefore, we get p plus q equals to 1. And if p plus q equals to 1, this implies q equals to 1 minus p. Here n and p are called the parameters of this distribution. Here n is what? N is the number of cases and p is the probability of the function. And there is a note. Suppose if x follows binomial distribution with parameters n and p, then it is usually write as like this way: x follows binomial distribution and p. When read as x follows binomial distribution and p, and it is write as in this way. Next, let me discuss mean of the binomial distribution. I have already told that binomial distribution is a discrete probability distribution. If suppose if x is a discrete random variable, then expectation of x is what? Summation of x into px. Here px is what? Probability mass function of x. And here px is defined in this way. Px is equals to what? ncx p to the power x q to the power n minus x. Therefore, expectation of x for the binomial distribution will be what? Summation of x into px. And px is what? ncx p to the power x into q to the power n minus x. And after calculating, we get expectation of x is what? In the last step, we get np into q plus p whole power n minus 1. And we know that p plus q is always 1. Therefore, expectation of x will be what? N into p. N into p. Therefore, we say that the expectation of a binomial distribution is NP. Thank you.